Yes, so for this program, we actually going to explore exploratory data analysis. And like we said in our previous class, it is actually a 3 weeks program where you're going to learn Python libraries like Numpy, Pandas, and Matplotlib. And you're going to use these libraries for the purposes of cleaning, exploring, and visualizing data effectively. So I want us to continue the program. Let's click on continue here. Let's click on continue here. Let's click on continue. Let's proceed with this program. Yeah, so this is where we are. So in our previous class, we did an outline, and the recording for the outline was actually uploaded here. So today, like if we actually go through the outline, we are broken down this program into phases. So we said that this was our week 1. We want to do now the introductory part to data handling using Numpy and Panda. So for this week, we're going to understand Numpy, how do you create Numpy arrays, how do you index, how do you slice, how do you filter Numpy arrays. So some of the application of Numpy arrays is that it will help you as a data scientist or a data analyst to efficiently handle large data sets. And also for scientific computing. Let's say you want to build a neural network. Okay. So that will be our first module. Today we want to introduce Numpy. Then later we are going to introduce Pandas. And Pandas will help us understand Pandas data frames and series, which are actually the foundational data structures for machine learning in Python. So you're also going to learn how to export data or import data from different sources, including CSV files, Excel, and JSON. So this is what our outline was entailing about. And now in week 2, we are going to do visualization. And then now starting from week 3, we are actually going to work on end-to-end projects. And then now we'll finalize by tackling capstone projects. For example, you can do a project for customer behavior analysis in e-commerce or retail platforms. Let's say a supermarket. We are going to analyze the climate change data analysis. We are going to do financial data analysis. We're going to do healthcare data analysis. So this will be our capstone projects. Now I want us to start. And as you can see, for this program to be effective, we had said that we needed some tools. And the tools are actually 4. The first tool you need is Python, of which if you've not done Python already, there should be a program for that one here. So you have to enroll to this program and complete at least 80% of the program. So if you have completed 80% of the program, then now you're allowed to start on EDA. So another tool that you need for EDA is Numpy that we want to start today. Tomorrow we are going to talk about Pandas, and then later we talk about Matplotlib, and then now we can now effectively use these tools for our EDA process. Let's go there. Let's start from now. Make sure you just click on this one, then you mark as complete. So if maybe you missed the class for the introductory part, you can actually go through the 42 minutes outline, and it will actually give you more information about what is our expectation for this program. So if you have already done this one, I just want you to mark it as complete. Mark it as complete. Mark it as complete. And now from there, we want to start on Numpy. So I hope you're there now. I hope you are there. Numpy. Numpy. Okay, so let's do our environment as usual. These are the guiding notes that will help us understand why we need NumPy, and how do we start using NumPy. So we're actually going through these notes here. And then there is a guide notebook that I want you to open. So click on this one, so copy. Then you can paste it here, Control V. Then you can open that one. So this is actually the notebook that you're going to use to understand NumPy. And from there, for our class practices, I want you to open a new Google Colab. Open a new Google Colab here. So we create a new notebook. Let's create a new notebook. And this notebook, we are going to call it NumPy Class Practices. So let's just say NumPy Class Practices morning session. That's what, yeah. So if you have that one, then I think they're ready to start. So you have the notebook where you're going to do your practices here. And this will be guiding us. Let me just share this one. This should be guiding us the class practices that you want to do. Let me share this one with you here. And now, if you are on the Jenga e-learning platform, then definitely you should be having these notes that will actually guide us on NumPy. So after doing this class lesson, I've already prepared some 8 questions that you can actually practice later, so that now effectively you can understand what is NumPy. So now we can start. So NumPy, sometimes it's called numerical Python. It's a powerful and efficient Python library for numerical computing. So those people want to do mathematics. It is widely used in data science because data science is made of mathematical operations. For those people who later will be doing machine learning, we're going to use NumPy and scientific computing. Let's say you want to do a research. So it provides support for multi-dimension arrays. And then you're also able to do some mathematical operations like cosines. And then we're also able to do linear algebra functions. For example, you can work with matrices, you can work with vectors, you can do transpose, determinants of a matrix, and so on and so forth. So with NumPy, it will enable fast and efficient data processing compared to the traditional Python list. So if you want to compare NumPy, there is even a comparison between NumPy and traditional lists. So you're going to notice that traditional lists are actually limited to some operations, unlike NumPy. So if you don't have NumPy installed, then we normally use pip install NumPy. Let's try this one. Let's assume we didn't have NumPy installed. What we start with is that we go to our notebook here. And like we had said that NumPy is a third-party module, we can install it using the pip command. But because this is Google Colab, you normally start with exclamation. So this is actually how you install a third-party library in Google Colab. So you start with exclamation, then you type pip, you install now the library NumPy. So let's say you're doing pandas, you can do the same. You just have pip install NumPy. Something interesting you're going to see is that when I run this one, Google Colab will actually suggest that NumPy is already installed. So remember we had mentioned that Google Colab comes with pre-installed libraries for data science. And I hope you can see that if I try to install Numpy, the Numpy library is already installed, like it's already pre-installed in Google Colab. So if you have libraries that are not installed here, then you can definitely install them using this command here. You start with the exclamation, you have this package manager, you use it to install the library Numpy. This is actually how you install a third-party module in your application. We said we normally use the pip command, and now we're using Numpy version 1.26.4. Okay, so if you have it already installed, then let's have our next code cell. You can actually import it as we can say import Numpy, and we can give it an alias name as NP. So NP will actually be a short form that we are going to use to represent Numpy. So if you want to call Numpy, then you can give it a short form name like NP that we're going to call the alias name. So this is actually the module. It's actually the module Numpy, and it provides us with the following operation. So you can actually do mathematical operation, you can do linear algebra, you can do Fourier transformation, you can actually do random number generation, and so on and so forth. You can even see that the whole documentation is generated for you inside Google Colab because they recognize the library. This is how you start. You first install the library, and then you use it in your application. Okay, I hope you're there. Make sure you run this too. So now I have Numpy library. So if I want to call the functions, I'll be saying np dot, then there will be a lot of functions here. For example, functions to do with argmax, there's a function to do with array, there's a function to do with average, there's a function to do with so I hope you can see there's a lot of functions that you're going to use here. For data manipulation, we have cosines, we have date time, whenever you want to work with daytime data. There is a function to do with dots, double, and so on and so forth. So this is actually a very effective library that we want to use for numerical computation. So I hope you're there. I hope you're there. Make sure you run this library. This is how you start. So going back to the notes, let me share this one now. So this is how you import Numpy. And share this one here. And we've already seen that Numpy, it's pre-installed in Google Colab. So if you were to use Jupyter Notebook or any other library like VS Code, then you needed to install Numpy so that now you can use it in your application. So moving further with this note, they're here. So Numpy is very useful because it comes with a data structure that we call Numpy Arrays. And Numpy Arrays is more powerful compared to the list data type that we discussed earlier. We're actually being told here that at the core of Numpy, there is what we call n-dimension array that we will later be calling Numpy array, n-dimension array. So n array, which is a more efficient alternative to Python list because it provides, Okay, so let's proceed. So at the core of Numpy, we'll actually have Numpy arrays. And Numpy arrays are more efficient compared to Python lists because it provides the following. Number one, Numpy arrays are faster in computation because they are optimized in C-based implementation. So this is more technical, but remember we say that Python, if you compare Python language and C programming language, C is relatively very fast. So C is a low-level language, so it's relatively faster than Python. So Numpy arrays, because they are optimized in C-based implementation, it becomes more faster, okay? Number two, we are going to see that Numpy arrays uses less memory compared to Python list, making our programs more effective. And then Numpy arrays also support vectorized operation, so that now you can apply operation to the entire array without using loops. So remember, if you are to deal with a Python list, then if you want to do some operation, you needed some loops, which requires a lot of computation. But with Numpy arrays, we have operation that can be done entirely on the arrays. So this is something we're going to see as we proceed. So as we proceed, we're going to see that we're going to start by how do you create the arrays? Okay, this is where we're going to start. And we're going to see that Numpy arrays allows creating different types of array. So we're going to see how to create what we call a one-dimension array. Okay, one-dimension array, and this is normally used in simple sequence of value like sales record or temperature reading over time. So let's say you want to analyze sales record, then you can store it in a one-dimension array. Or let's say you want to read temperature over time, then definitely you can work with a one-dimension array. So we're going to see this one, and we're going to differentiate one-dimension array from two-dimension array. So two-dimension array, you're going to see that it represents data in tables, such as, let's say you want to represent student score in subjects, so that now you can represent them in rows. So the row will represent the students, the column will represent the subject. So two-dimension array will be the foundation of tabular data, so data that is represented in a table format. And then also later, we're also going to see three-dimension arrays, and it is normally used for storing complex data, such as multiple sets of images or climate data over several times. So these are, at some point, we're going to call them tensors. And normally we use three-dimension arrays to represent images in pixel format, okay? So the first thing you're going to learn is how do you create these arrays? How do you create Numpy arrays? Number two, as we proceed, we are going to see now what are the properties of Numpy arrays. So we're going to talk about the shape, which tells us the dimension of the array. N dimension shows us the number of dimensions we have in the array. We're going to have the size, tell us the total number of elements in the array, and then finally, the D type to display the data type of the array element. So it could be an integer, it could be a float, it could be an object, and so on and so forth. So after understanding the Numpy array properties that you want to do today, it will actually help us in understanding the structure and storage. This property will help in understanding the structure and storage efficiency of an array, okay? So after now understanding array property, we are going to learn how to use built-in function to create some arrays. So we can create an array of zeros and ones. We can use an array to create an identity matrix. We can actually create a random array using the random number generations. Or we can also create an array using some sequence data type, for example, the range and the line space. I think we discussed the range. We say that the range, we actually specify where you start, where you stop, and the steps you take. Okay, so this is something we're going to actually clarify in our class practices. Basically by using some of the Numpy built-in functions to create arrays. So this will be our third module. Now moving further, we're also going to discuss now, how do you index or how do you slice elements inside array? So you're going to see that Numpy allows efficient indexing and slicing for extracting specific information from the array. So you're going to see that indexing is whereby accessing element using their position. So let's say you want an array at index 0 will receive the first element. We're going to see negative indexing like we did in Python list. Slicing is whereby you want to extract sub-arrays or part of the array, sub-array, like a subset of the array. So it could be a single row from a two-dimensional array. It could be a specific column from the data set, and so on and so forth. So basically, after discussing indexing and slicing, this will help us now extract information from Numpy arrays. And then now from there, now we're able to apply some mathematical operation to the information that is stored in the array. So for example, you can do some basic operation like addition, fraction, multiplication, division, exponential, and modulus. You can also perform vectorized computation. Okay, we can actually, unlike Python list, Numpy execute mathematical operation without using loops. So we are going to see this is very important. And we're also going to do some statistical operations, like we can actually get the mean, median, standard deviation, count, the sum, and so on and so forth. So why you should learn this mathematical operation is because these operations are crucial in machine learning and data science for handling numerical data efficiently. So let's say you're doing data science or machine learning, and you want to work with the numerical data, then at some point you will need to perform some mathematical operations. So this mathematical operation, we have some functions in Numpy that will help you perform this operation. That will be our fourth module in Numpy. And then now we are going to finalize by talking about reshaping and transposing. And you're going to see that this will actually help us perform what we call data transformation. Okay, so you're going to see that Numpy allows restructuring arrays without modifying their data. So we're going to talk about a function called reshape. We're going to talk about transpose. And you're going to see that reshape is whereby we convert a raw. Let's say you want to convert a raw image pixel data into a structured format for deep learning models. Okay? Or let's say if you are doing transposing, then maybe you want to transposing a data set where features and observation need reordering. Let's say you want to do some reordering. So in summary, here we are going to start by talking about what are Numpy arrays. That is where we want to start. Number 2, we are going to discuss the Numpy array properties. Number 3, now how do you create these Numpy arrays using some built-in functions in Numpy? So that is what you're going to learn. Then now, how do you now start extracting information from these Numpy arrays? Either you can work with indexing or slicing. Then number 4, how do you perform mathematical operation with the purpose of manipulating data that has been stored inside a Numpy array? And then finally, we can talk about reshaping whenever you want to reorder or transform information that you've stored inside a Numpy array. So for all this information now to make sense to us, now I want us to go to this column, but I think I should actually have some summary here. Is that Numpy is an essential tool for efficient numerical computing in Python because it offers fast memory efficient array operation compared to Python list. We'll be having some built-in function for statistics, for linear algebra, let's say you want to do calculus, and also for complex computation. We're also going to see that Numpy array is very powerful in indexing and slicing information. And also we are going to see that Numpy is very powerful for reshaping and transposing data for flexible data structuring. So therefore, by mastering Numpy today, developers or data scientists, you can actually optimize your performance. You can actually simplify your data processing, and then you can also enhance your ability to work with numerical data in the fields of artificial intelligence, machine learning, and scientific research. That's why we actually starting with it today, so that now later we are going to apply it in our AI models, in our machine learning model, in our also our scientific computation. So let's do some class practices here, so that now we are ready to effectively understand NumPy. So I hope you're ready. Let's down there is a question. So any question up to there? Any question up to there? Okay, so I think now let's proceed here by now doing some class practices with the purposes now of understanding NumPy arrays. Okay, NumPy arrays. So if you're ready, I would wish now you open this notebook here. So let's open this notebook here. I hope you're there. Make sure you're there. Open this notebook. This should be guiding us on what you're going to practice. From there, it will actually tell us how do you index and slice, how do you perform mathematical operation, and so on and so forth. Some of the exercises, I've actually uploaded them there. Also, you need this notebook so that now you're able to do your own class practice. I want us to start from here. Let's have a code cell and say that today we are actually discussing NumPy as a numerical computation library. So this one means that you are able to do mathematical operation like in linear algebra. So if you are doing a linear algebra, so this means that you can work with matrices and vectors. You're also able to do calculus operations. You're also able to do calculus. That is how the spelling is, and also able to do statistical operation. So it's actually the foundational library for any mathematical operation you want to do in your data science or data analysis process. So by the end of this class, these are the objectives. Let's just outline the objectives because we have a lot to cover. So let's talk about the objectives. Number one, by the end of this program today, I hope that now you are able to understand what are Numpy arrays. That is my first objective. I hope you to be able to understand what are Numpy arrays. So you're going to see that in other places or in other articles, they are normally called n-dimension arrays and arrays, that one, okay? Because you're going to see that you can have a one-dimension array, you can have a two-dimension array, you can have a three-dimension array. So that is my first objective. How do you create? First, you understand these Numpy arrays and their properties. Very important. Their properties. Okay, that is the first objective in this program. Okay. The next objective is how do you create a Numpy array? So how do you create a Numpy array? Using built-in functions in Numpy. So how do you create them? First, you've understood them. Now, how do you create them? Maybe using Numpy arrays in Python. Then from there, that is what we are discussing. I just want to summarize it so that now people can understand what you're doing. So I've talked about properties. How do you create them? Number 3 now, as we proceed, you also want to discuss, so this is C, you also want to discuss how do you index and slice information from a Numpy array. So this will actually be helpful in getting information from a Numpy array. I want you to imagine a Numpy array is where now information is stored. So let's say I want to get the top student in my data set, but I want to get the county where malaria has concentrated. I need to know how to extract information from a Numpy array to help me now be able to get information from my project. So see, after now getting information, how do you perform mathematical and statistical? How do you perform mathematical and statistical process in a Numpy array? So this will actually help us do what we call data manipulation. This would be here. You help us now perform what we call data. I think this, I should have said this is actually helpful in data extraction. And now this is very, very helpful in data manipulation. So I hope you can relate how this will be. This will be very, very helpful in data mining. If you want to create information, then you are mining that data. So this will be helpful in data mining. This will be helpful in data extraction. This should be very, very helpful in data manipulation. And then finally, E, we're also going to learn how to reshape and transpose data in a Numpy array. So why this is helpful is because it will help us in what we call data transformation. So you want to transform the information that is captured inside a Numpy array. And you are going to see that data mining, data extraction, data manipulation, and data transformation are effective procedures that is actually done by most data scientists and most data analysts out there in the market. So I want us to start one by one. I want to give you this outline. I've actually broken down that outline. Let me share this one. Yeah. So Victor, you're saying you're not able to see my screen. Can you see it now? Can you see it now? Perfect. Okay. So I hope I've shared to everyone. Again. Okay. So I've now shared all the outline to everyone. So this is actually why we are learning Numpy. I hope you've seen that. I've actually broken it down. Sharon, you're asking, are we installing Numpy? That's a very good question. The answer is, if you are to install Numpy in this project, then the command you are to use is pip install Numpy. Because this is Google Colab environment, we normally start with an exclamation mark. So now if you run this project, what you're going to see very interestingly is that Numpy has already been pre-installed in a Google Colab environment. So this, like we had mentioned while starting on Google Colab, we say that Google Colab comes with pre-installed libraries. And one of the pre-installed libraries is Numpy. So you don't even need to install it because it's already existing in a Google Colab environment, okay? But other libraries, you see they are not available. So in case you have a library that is not available in your project, then this is how we are going to install it. We start with an exclamation mark. We have pip, we install Numpy. So you don't need to install Numpy because it's already satisfied. It's already there. So what you just need to do is to import it here. So you can import it as NP. And now, if you have Numpy in your project, you're able to do data mining by actually creating some Numpy arrays. You're going to see this one very fast. We're able to do data extraction by indexing and slicing information from a Numpy array. We're able to do data manipulation because such that now we're able to perform mathematical and statistical procedures to a Numpy array for the purpose of manipulating data that you have in a Numpy array. And also you can reshape information in a Numpy array with the purpose of now doing what we call data transformation. Okay, I hope I've answered that one. I hope I've answered that one. So you don't need to install it, it's already there. It's already there. Just wanted to show you that Google Colab have this pre-installed library. Even Pandas is already there. If I try to install Pandas, let's demonstrate. This is what we are going to do tomorrow. If I say pip install Pandas, pip install Pandas, you're going to see that Pandas is also there. So Numpy is already existing. Pandas is already existing. All the components that we need in Pandas, it's already there. And this is one beauty of Google Colab that we don't have with other IDE platforms. So if you are using a platform like VS Code, then you should first install Numpy. You should first install Pandas so that now you're able to use it in your project. But now this is not needed because they are already satisfied in our project. And just have Numpy. I can even remove it. I don't need it because it's already there. But just for demonstration purposes, it's good for you to see that Numpy is already existing in Google Colab environment. So these are the objective we have. So let's start. Let's start. Unless there is another question. Unless there is another question. So no question. So let's proceed. Let's proceed now. So we want to use this one to guide us. So let's have it here. So we're being told that Numpy is very powerful especially if you're doing numerical computation. And it will provide support of multi-dimension arrays. You're going to see that Numpy have mathematical functions. Numpy will have linear algebra operations, and it will actually make it an essential tool for data science, machine learning, and scientific computation. So I've mentioned that if you want to install Numpy, go with this command, say pip install Numpy. But if you're using Google Colab, don't need to install Numpy because it's already existing. Now, once you've installed Numpy, you can import it in your using the Python script here. So you can actually say, I want to import Numpy as NP. Make sure you have it here. I've already done that one. So make sure you have imported Numpy as NP. So I want you to imagine this Numpy is a module. So it comes with built-in functions for numerical computation. Okay, that is very important. Now, let's start with now Numpy arrays. Numpy arrays is where we have an array that is more efficient than a Python list. Okay, so I hope this one will really make sense. We want to start by now creating Numpy arrays here. Okay, so let's start by now talking about how do you create a Numpy array. So in some other words, we'll be calling them Ndarrays, because they are made in dimensions. And you're going to see that they are more efficient than Python list. So to effectively create a Numpy array, I want to start here. I hope this one will really make sense. So number one, creating Numpy array. So this is something I really wanted you to see. Please look at this one here. So you can have student marks in a list. So you can have a list, okay? Okay, for example, the first student scored 89. The next student scored 6. The other student scored 67. I only want 5 students. Another student scored 90. And then finally, I have a student who scored 45. So these are student marks, okay? So if I see, let's see the data type that we have in these student marks here. So if I now say, I want to print the type. So remember in Python, you are using the type function, and then we pass our variable. And then we are being told that this student mark is a Python list. I hope you can see here. We say that a list is any collection of data inside a square bracket. So you're also seeing that we want to say here that we can convert a Python list to a Numpy array, so that now we can make the operations more efficient and more faster compared to a Python list. So being told that if you want to manipulate data in a Python list, then this is not more efficient, especially in data science and AI. So the best way you can manipulate data in a list is by converting it to a Numpy array. So how do you do that one? I can now say, this is now the student marks as an array, Numpy array. We are going to now say, let me just import it here. just import, just say import numpy as np. So we've imported numpy as np. So therefore, I will use numpy that I've imported. There is a function called array. Then you can pass now your list, student marks. I hope you can see that one. So these student marks that I had initially, I've passed it here. And now if I print the data type, I'm going to get that this is a numpy array. It's actually a numpy array, okay? So the first thing you can convert is a list. I hope this one will make sense. So you can work with a list. So if you have a list, you can convert it to a numpy array, okay? By definitely taking that list of students and then calling the function called np.array, numpy.array, okay? Then you pass out the list. Now, definitely the list will be converted to a numpy array, then you store it here, okay? Alternatively, we can also work with number 2. Even a tuple can be converted to a numpy array. So remember we said that a tuple is where we have collection of data inside a rounded bracket. So if you run this one, this is actually a tuple. I hope you can see that one. So let's see whether you can convert a tuple. And I'll say student marks array, student marks array. I can call the function numpy.array, and then I pass the tuple. Let me see whether I'll get numpy array, and still I'm getting a numpy array. I hope you even have range. Let's also have range. Let's also have range. Number 3, range. So remember we did a range function, okay? Range function. So you can even say that we have student admission numbers. And let me just say student registration numbers. We can actually get them in a range function starting from 1001. So let's say the student registration number 1001 all the way to 1016 or 6. Let's just say 1006. That one, yeah. So if I now print I'm also getting numpy arrays. So I wanted you to see that you can convert a list, a tuple, or a range to a numpy array by definitely calling the np.array function. So this is something we are going to note here. We're going to note here that using np.array function, we can pass a list, we can pass a tuple, or we can pass a range, and to convert, so this using that one, we can convert this sequence data type. So remember we did this one in Python, so we can convert this sequence data types to numpy arrays, okay? So remember we did sequence data types in Python. We said we have a list, we have a tuple, and we have a range. By just calling the function np.array, we are actually able to convert it to a list, from a list a tuple arranged to a Numpy array that we are now actually calling them Ndarrays. Okay, so let me share this one with you here. In case you have a question, you can ask. But definitely, this is how we create a Numpy array. So we create them from a list, a tuple, a range. I'm not sure about sets and dictionary, but I'm very sure if you have a list, if you have a tuple, if you have a range, we can actually convert them back to a Numpy array. So I want you to try this one and confirm whether you're getting the same output as mine here. So I have a list of student marks. If I even print their type, it's a list. But if I want this one to be an array, I just call the np.array, the function here. np numpy.array, and then inside numpy.array, I pass now the data type. This was a list, I can pass it here, and then I get a Numpy array. Similarly, if I have a tuple here, example here, if you even print the type, it's a tuple. So I can now take this tuple and pass it inside the numpy.array, and then I get a Numpy array. Similarly, I can also work with the range function. So it's very important to understand, because it's the first way now you can create a Numpy array. So going back to the notes that I have. Let's check the notes here. We are being told that if you want to create a Numpy array, you can actually call the np.array. Then you can pass either a list, you can also pass a tuple, you can also pass a dictionary, not a dictionary, but a range. And then definitely we are going to get a Numpy array. So let's copy this one. Let's copy this one. And then now we can paste it here. So this is a one-dimension array. So one-dimension array. So a one-dimension array is just one sequence. Like for example, this one here. This is a one-dimension array. I have an array by just calling the numpy.array, then I pass my list. So if you pass your list here, you get a numpy of a one-dimension array. Okay. This is a one-dimension array. This is a one-dimension array. So how do you know this one? By now getting the properties. Let's get the properties. Properties. How do you confirm that this is a one-dimension array? Okay, let's get the properties here. That's how the notes have been structured. Okay. So I want to copy this one. I hope this one makes sense now. I want to copy that one. I paste it here. But this is array 1, not array 2, but array 1. I will share this one with you, so you don't have to worry. Array 1, array 1, array 1, and finally, array 1. So this is a one-dimension array. Let's confirm that one first. Let's confirm that one. So if I run this code here, I'm being told that this is the array. Okay. So the shape talks about the shape of the array. I think this one will make sense if I now do a two-dimensional array. We have 5 by something shape. Then the dimension, this is what I wanted you to see. The dimension. So if you want to get the dimension, you just take your array, then you print the n dimension, number of dimension. I can be sharing this one first with you. Share this one here. That one. So now we are saying that this was my array where I use np.array, numpy.array function, then I passed my lists. You can, like I've said, you can pass a list. You can also pass a tuple. You can also pass a range. All of them, we are actually going to get a numpy array. So we want to confirm that this is definitely a one-dimension array, okay? So if you print the shape, then it will be told that you only have 5 elements in a single dimension. 5 elements in a single dimension. 1, 2, 3, 4, 5. 5 elements in a single dimension. Number 2, if you print the number of dimensions, we only have 1 dimension. I hope you can see that one. If you print the size, so size talks about the total number of elements in the array. So we are being told that we have 5 items in that array. So we have 1, 2, 3, 4, 5. And then finally, the last property we have in Numpy arrays are the data type. So if you say array 1, I want to see the data type, then you're being told that the data type of a Numpy array is integers. They are actually integers in 64-bit operating system. I hope you can see that one. So something to note here, NB, and please always remember this one, NB. Please always remember this one. A Numpy array can only store values of the same data type. So please always remember this one. So they are normally called homogeneous. So being told that a Numpy array, these are also a very important property to note. We can only store values of the same data type. So if you want to store numbers, then just go with numbers. I cannot put here a string. Let me try a string here, like Eric. Like this one. So remember, these were numbers, and this is a string. So if I try to run this one, definitely you should have an error. You see, even we cannot even get the exact data type for this Numpy array. So remember all the time that a Numpy array can only store values of the same data type. So it's always advisable to avoid mixing data type in a Numpy array like that one here. So I hope this still not make sense, but now if you do the next one, if you try out the next one, it will now make much more sense. Let's try out the next one. Let's try now a 2-dimension array. So this is a 1-dimension array, just array in one line like this one here. How about a 2-dimension array? So a 2-dimension array. So let's have a code cell here. Then now we talk about a 2D array. So here, so a 2-dimension array. Now this would now try to now clarify everything here. So if you press this one here, so a 2-dimension array is whereby we have the outermost array. This is the outermost array. This outermost array, as you can see, it's outside. It's having 2 dimensions. The first dimension is here. The next dimension is here. So they are actually inside the outermost array. Okay. So now, if I now copy these ones here, just alternatively, I can now copy the ones I had here, and I'll share this one with you. Now we can actually make a comparison. So if you run this one, we can actually make a comparison. It's like a matrix. Very beautiful to see. So let me copy this one, and then I paste it here. So that is a 2-dimension array. So can you see my screen now? So I don't know. Someone is saying that you are not able to see my screen. Can you see my screen now? Just confirm. Anyone who is not able to see my screen? Okay, thank you. Okay, let's make a comparison here. I want us to see this one clearly because it will be very, very helpful in our subsequent classes. So if someone is saying that you are having a 1-dimension array, it is an array in one sequence. I hope you can see that one. It is an array in one sequence. I hope that one makes sense. Now let's go to the two-dimension array. So if I try to print a two-dimension array, you're going to see that we have two rows. This is the first row. This is the next row. Like we are representing them in a row, something like a matrix. So this array is having the first dimension, the first row, the second dimension, the second row. Okay? So this is what we call a 2D array. We have arrays represented in a row. The first dimension, and then the second dimension. So I want us to see that they're represented in rows. This one here. Okay? The first dimension, the second dimension here. Like we have that one there, but I think I'll clarify that one again. Now, that was the array. If I print the shape, I think I should have even added this one. Let's add this one here so that we clearly see what I mean. I want this one to make sense. So now, if I print the shape, let's check the shape. Let's check the shape. Very important to see. If I print the shape of this array, then I'll be told that this array is made up of two rows, the first row, the second row. Can you see 2 by 3 columns? So 1, 2, 3. So it's a 2 by 3 matrix. So the shapes talks about the number of rows you have, okay, and the number of columns you have. So you have 2 rows, the first row and the second row. So those are 2 rows. I hope you can see that one here. And then the other shape is now talking about the column. So we have 2 rows and 3 columns. So the first column, second column, third column. So if I were to add another list here, I hope this will not be confusing. So if I add something like that one, let's see what now would happen. We are going to have 3 rows. So if I now print the dimension, if I now print the shape, please see the shape, we have 3 rows and 3 columns. So it's a 3 by 3 array or matrix. In other words, so it's like now you're working with a matrix. And I hope you can see that now we are working in a tabular data, because tabular data is a data that is represented in rows and columns here. Okay, this will be very, very useful later, as you're going to see. But let me just retain the way it was initially, like that one. So we have 2 rows and 3 columns. Okay, that is what we call the shape. So if I'm talking about the shape, it represents the number of rows and columns. So in the first one, we only had 1 row and 5 columns. So you only add 1 row and 5 columns. So you don't have to specify that we have 1 row. You can just say we have 5 columns. 1, 2, 3, 4, 5 in 1 row. But here we have 2 rows and 3 columns. So it's a 2 by 3 matrix. Now, if someone talks about dimensions, this data has been represented in 2 dimensions. The first dimension represents the row. The second dimension represents the column. So we have 2 dimensions. One dimension, we have the row. Second dimension, we have the column. So this is a 2-dimension array. How this one makes sense to you? How that one makes sense to you? And then if someone talks about the size, we are now talking about how many elements do we have in that Numpy array. So we have 6 elements. So we have 6 elements, 1, 2, 3, 4, 5, 6. But these 6 elements have been represented in a 2 row and 3 columns array. And then finally, the data type represents the data type of these elements in the array. So we can have them as integer in 64-bit. So any question up to there? Any question up to there? Something I'm trying to. So there's something I'm trying to recall that will really help us here. This one, but I think I'll get it in a short while. Let me just get it very fast. I'll get it in a short while. But as we proceed, I'm going to get a way to display these arrays so that now we're also clearly able to understand them. So any question about now, these are one-dimension array. This is now what we call a two-dimension array. So let's even try one more. Let's even go deeper and see now a three-dimension array, which is even very, very complex. And the three-dimension array, we're going to see that they are normally represented in deep learning applications. Like whenever you want to deal with images. So let's try three-dimension array. Three-dimension array, so 3D array. This was a 3D array. This was a 3D array, so let me copy that one. I add a code cell, that one. So this is what we call a three-dimension array. So let me print now the properties, the shape, the dimensions, the size, and the data type. So if I run this program, I'm being told that this is a three-dimension array in such a way that we have two rows. This is like for the x-axis, this is for the y-axis, and this is for the z-axis, a 3D array. So the number of dimensions are 3. The total number of elements, they are 8. And then we have integers of 64-bit. Integers of 64-bit operating system. So this is what we call a three-dimension array. So I can even confidently say that for starters, we are going to work with either a one-dimension array and a two-dimension array from now. And then later, as we are going to do some deep learning operation, then now we'll transition to even more than three-dimension array. We can work with the four-dimension array, five-dimension array, and that's where we'll be needing some knowledge to do with deep learning. Deep learning. So I want to share this one with you, and then you can ask me any question from there. So that is a three-dimension array. That is what you call a three-dimension array. So we have a one-dimension array, a two-dimension array, and a three-dimension array. So you give me a second, I get for you a piece of code. I want to get you a piece of code that you can actually use to display this dimension arrays. So just a minute, I get them here for you. So just a second. I'm trying to get for you a way to display these arrays. Okay, looks like I will have, I think I will share that piece of code later. I'm not able to find it, but it will be very, very helpful to show you how you can actually display and actually a dimension array. I think it will be very, very helpful for that piece of code. I will share with you later, so that now when you use it here, you can actually see the difference between a one-dimension array, a two-dimension array, and finally, three-dimension array. So any question with creating arrays? Any question with creating arrays up to there? So if no question up to there, I hope now you understand. This is actually the most complex part, to differentiate between a one-dimension array, a two-dimension array, and a three-dimension array. Okay, if that one makes sense. I think the one that is very complex is a three-dimension array, but you're not going to use it yet. So what I really want you to understand is either a one-dimension array and a two-dimension array. So proceeding with that one, in the notes I have here, now we've talked about properties. So we have a use case of everyone. So for example, in the one-dimension array, you might want to have a retail stock track for your daily sales in a one-dimension array, where each element represents the sales of product for 5 days. So you can actually want to use a one-dimension array to represent your daily sales. Or let's say a two-dimension array, you can use it. For example, whenever you have a school track student score in 2 subjects, whereby we have the rows to represent the students, and then the column to represent the subjects. And then in that three-dimension array, we can have a weather department store, temperature reading over multiple days across multiple locations. That's something you're going to see. So that is very important. Now, let's go to creating arrays using built-in functions. Very important. Creating arrays using built-in functions. So let's add a code cell here. So here, time is already moving fast. So creating Numpy arrays using built-in functions. So creating Numpy arrays using built-in functions. Very, very important. So we have several functions that we can use to create Numpy arrays. So according to the notes we have here, there is a function called ones. You also have zeros. So let me just have this one here. So I can copy this one here, copy this cell here. I can just paste them here. Not that one, sorry, Control Z. So sorry for that one. It's happening unless I just copy the code. So if you say ones, so let me start with number A. Let me just read very slowly. We also have np dot ones, dot ones. So let's see what this one does. So if I now say np dot ones, and then I put like 5, let's see what would happen. It will create for me an array of ones having 5 elements. So it's normally represent them as floats. I hope you can see 1.1. So this is an array of ones. So if you say 3 by 3, let me even say 3 by 3, it will have 3 rows, 3 columns. Let me just show you that one. Sorry. Just a minute. This should be actually, sorry for that one. Should be, you actually need to pass the shape. You need to pass the shape as 3 by 3. Sorry for that one. So if you run this one, then you are getting an array that we are representing numbers as 3 rows with 3 columns, each having ones. This is what we call ones. So another alternative way of doing this one, you can even say I think that should be the case actually. You're actually representing them. I think now let me see. NP. Yeah. 3 by 3. This should work. I think it's not fitting. Okay, so I think I can just pass it the way it was initially. 3 by 3. So we are going to see that we are having ones of the same. Let's say 3 by 3 ones. Another way you can do it is by now using zeros. So NP dot zeros. And then say I want to represent 2 by 3 zeros. So if you run this one, now you are getting that we are having 2 rows with zeros and then 3 columns here. So it's actually one way you can use to create arrays either by using np.ones and np.zeros. And we are seeing that this creates an array, creates an array with zeros and ones as float data type. I've seen that one here. We are creating them as float data type. So I want to share this one with you. This is one way you can use to create a Numpy array. That is one way you can use to create a Numpy array. So can you see my screen? I'm not able to see my screen.
Yes.
Can you see my screen?
Yes, we can.
Okay, okay. I think there's also a very good question here for someone from Gianna. You're asking for me to pardon 3-dimension arrays. Yes. So what I can actually say is that a 3-dimension array is an array with x-axis, y-axis, and z-axis. So I think what will be very helpful there is when I actually share the code so that you can actually see them visually. But something that will be very promising is that for now we are not going to use a 3-dimension array yet. We'll first start with a 2-dimension array where we have rows and columns, or a 1-dimension when you only have columns represented. Then later, as we'll be doing deep learning, we'll be now transitioning to a 3-dimension array. So as you can see here, just if you check the shape, if you want to understand a 3-dimension array, you can actually check the shape. The shape is actually having on the x-axis, the rows, we have 2 rows. On the y-axis, the columns, we have 2 columns. On the z-axis, we also have 2 values on the z-axis. So this is actually a 3-dimension array. A 2-dimension array is where we have the rows, columns. So we have x and y. And this is when you only have x. You only have x, 1 dimension. Y, 2 dimension, you have x and y. 3 dimension, we have x, y, and z. But I think I'll be sharing a certain code so that now we can display this one visually so that now you're able to understand them clearly. Okay. So moving further, so this is actually one way you can create arrays using ones. You can also create an identity matrix. You can actually create an identity matrix. So we're still on creating arrays. the identity. For those people who are doing linear algebra, then I'm sure would understand what is an identity matrix. So let me say this one. Just print your identity matrix. This one. So this is what you call an identity matrix. So if you have done linear algebra, then an identity matrix is where we have this one represented in a diagonal. So this is an identity matrix of 4 by 4 matrix. If you say 3 matrix, then you're going to see that this is the identity matrix of a 3 by 3 matrix. It's called the identity matrix. Very, very useful, especially for those people who are doing linear algebra. For example, if you're doing something to do with Gaussian elimination, then you need some identity matrix. So this is an identity matrix for a 3 by 3 matrix. If you say 2, then an identity matrix of a 2 by 2 matrix looks this way. There's actually another way you can create a matrix. It's by either using ones and zeros. You can work with an identity matrix. And then finally, D, we'll share this one with you. I'm sharing this one with you. That is an identity matrix. And then from there, we also have using random arrays. So that is A, B, then C, using random arrays. Using random arrays. Okay. So to demonstrate this one, we can have an array of number in a certain random. So for example, let's start with this one here. Let's start with this one here. So here we are actually creating an array of random values between 0 and 1 of a 3 by 3 matrix. Let me see what happens here. If I say random array, then as you can see, we have a 3 by 3 random numbers between 0 and 1. So if you say np.random.rand, then it will actually give you some floats between 0 and 1. Floats between 0 and 1 of this array. So we have 3 rows, 1, 2, 3, and now we have 3 columns here. So it's actually a random number of 3 rows and 3 columns ranging between 0 and 1. So if I run it again, I'm getting another random numbers in the same range. Alternatively, if you wanted them to be integers, so you see by default, so they are actually float 64 by default. That is, if you don't actually specify some parameters, then by default they are floats between 0 and 1. Alternatively, if you wanted them to be integers, just actually have this one here. If you wanted them to be integers, so I think I should have said this is number 1 as floats, so random numbers as floats. 2, here we have random numbers as integers. So as integers. So for example, here we're saying that I want random integers, so I just have to say numpy.random.random int. So you need to add random int. If you want float, then you just have to say random. Here you want to say random int between 1 and 10, and I want to represent them in a 3 by 3 matrix. So if you run this one here, I think I should have printed them here, so I can just say random ints. So if you run this one here, then definitely you're getting random integers between 1 and 10, That is between 1 and 10 in a 3 by 3 matrix. So you have 3 by 3 between 1 and 10. You can even say between 1 and 20. 1 and 20. So if you say between 1 and 20, then the integers will range between 1 and 20 in a 3 by 3 matrix. So if you want to get them as integers, then definitely you need to pass the random int. If you want them as floats, then you can pass random. So this is also another way you can use create a Numpy array. So I'm also sharing this one with you. It will be very, very important later. Share that one with you. So we have random as floats and random as integers. So moving further, I hope you can still see my screen. Moving further, we can also create an array using some sequences. So that is D. So that was D. D. Using some sequences. Sorry, using some sequences. So if you're talking about sequences, then you can have, the first one is a range. A range. So, first, I would share that piece of code. So we can actually now see the first one you can create using sequence is what we call the Numpy dot a range. So it's very, very similar to the range function. It's very, very similar to the range function. And the a range, we normally have the start. We have the stop, and we have the step. So for example, in the code that you're seeing below there, we want to start from 0. We moved up to 10, and we take 2 at a time, 2 steps at a time. So we start from 0. After 2 steps, you go to 2 up to 8. So if I run this program here, range array, not run, but range array, that one. So if you run this piece of program here, then you're getting that we have started from 0. We want to stop at 10, so therefore we go up to 8. So if I was supposed to stop at 10, then I'll go up to 11, like that one. So this is where you stop at 10. Because we say that the last value is normally excluded. So let me just reduce the way it was to 10. And then we take 2 steps at a time. So we've actually created a Numpy array. Alternatively, we can also work with a line space. So np dot line space. And I hope you can see this one based on the guideline I have here. Just show this one. Okay, this one here. It's normally called the spread operation. So line space array. So if you run this piece of code here, so what is happening here is that I want an array that starts from 0 up to 10, and then I want to spread them in 5 elements. So if that is 0, then if you want up to 10, 5 elements, then each element will be actually spread in a fraction of 2.5. So 0 we go to 2.5. From 2.5 we go to 5. From 5 we go to 7.5. From 7.5 we go to 10. Okay. So let's say I wanted an array between 0 and 100, and then I want to spread them in 5. So if you run this one, then you're going to see that we start from 0, we go to 25, we go to 50, we go to 75, we go to 100. If I want them to spread them in 4, say 4, then you're going to see that we have 0, then we have 33.3, we have 66.6, then we have 100. So this is what normally called the spread operation. So if you say 10, then now you're seeing that we have 0, this one. So we're actually spreading them in 10 values. So let me return them as 5. As 5. Now you can see this is what we call the spread operation. So these are the 4 ways you can actually use to create a NumPy array. So the first way I've mentioned is by using, so let me just repeat that one, very important. So if you want to create a NumPy array, the first way you can do it is by using zeros and ones. Okay, zeros and ones. So ones will be creating an array of ones. Zeros will be creating an array of zeros, and they're actually as floats. Okay. Another way you can use is by actually defining an identity matrix. So you said an identity matrix is whereby we have these ones in a diagonal. So you can have an identity matrix of 2 by 2. You can also have an identity matrix of 3 by 3. So long as these ones are in a diagonal, this is what we call an identity matrix. Finally, not finally, but C, we said that we can also create an array using random numbers. So if you want floats, you can just go with numpy.random.run. This one gives us a floats, random number in floats. Then if you want them as integer, you can just say numpy.random.randomInt. But here you have to specify the range that you want between 1 and 20, then the matrix that you want. And then finally, you can also create NumPy arrays using sequences. So you can work with a range whereby you specify the start, the stop, and the steps you take. And also you can create an array using what we call the line space in such a way that I want an array that ranges between 0 and 100, and I want to spread them into 5 items. Okay? And now you're getting the line space here. So any question on how to create a NumPy array? That was our next objective. So we have actually learned how to create we've understood NumPy arrays and their properties. I hope now you're able to create NumPy arrays using built-in functions. So moving further, that is if you don't have a question, no question yet. Now we can go to indexing and slicing arrays. That is that was our third objective. Indexing and slicing NumPy arrays. We are in our third objective. So far, so good. Sorry for not here. Here. So now we are in our third objective, still on NumPy. So we are talking about number 3, objective 3. So this is objective 3. And we are now talking about indexing and slicing NumPy arrays. Indexing and slicing NumPy arrays. And we say that the basis of learning this one is for us to be able to extract, so that now we're able to extract information that is stored in a NumPy array. And this will be actually help us in data extraction. So to do this one, we are actually being told that if you have a one-dimension array, so we'll start one by one. Number one will start by one dimension array. So let me just copy something like that one. So if now you run this one, now you're seeing that now if I want a certain element, I just need to pass the index. For example, if I want 20, then I can just pass the index for that value, then I get, if I want the last element, then I can just pass the index for the last item as negative, okay? So if I were to slice, so this was indexing. This was indexing. A one-dimension array. You can also have slicing. A one-dimension array. So slicing a one-dimension array. So for example, if this was my array, here, this was my array, and I want to get, just have this one. So I want to get from 1 up to 4. So this one will give us an index that is ranging from index 1 up to index 3. So I've sliced from index 1 up to index 3. So index 1, I have 20. Index 2, I have 30. Index 3, I have 40. So if I want to slice them this way, then I'll actually get them in this order. So this is something we did on Python. List is the same for a one-dimension array. For a one-dimension array, it's very, very similar to a Python list. If you just want an item, just extract it by its index number, either in a positive indexing or a negative indexing. So this is something we did in a Python list. Alternatively, if you want a certain sub-list or a subset of this list, then you can definitely pass the range. So if I want to start from index 1, if you put 4, then you're actually going up to index 3. So therefore, you're getting 20, 30, and 40. 20 at index 1, 30 at index 2, 40 at index 3. So it's something we did on Python list. So now the next part that will be now a bit complex is now slicing a 2D array. So slicing a 2D array. So remember, you should be reading the use case. For example, for a 1D array, you can actually be using this one to extract specific element from a data set, such as, let's say you want to retrieve the temperature of a particular day. Now moving to a 2D array, moving to a 2-dimension array. So now here I'm talking about 2, indexing and slicing 2-dimension array. I can use this code. So if you run this piece of program, okay, let me first print them. Let me first print, just print the array. So this, I want to print the whole element first. So first I want to print the whole element. Then I can have a separator, this one here, the one I've been using. So if you run this piece of program, this is your array. This is your array. Okay? This is your array. Okay. So in this array, if I want the first row, please check, this one is very important, especially for those people who will be doing machine learning later. This will be very, very useful. If this is my array, this is the entire array. This is the entire array. I think I should also have another operator here, because what's happening? That one here. It's good for us to see. Yeah, like that one. So if this is the entire array, if I want the first row, I'll just say that I want us to see this one. At index 0, I have this row. I hope you can see that one. At index 1, I have this row here. At index 2, I have this row here. So what happens here is that the first row, it's at index 1. The second row it's at index, this is at index 0, sorry, this is index 0, this is index 1, this is index 2. So you can actually see it's presented in a list, the first row at index 0, the second row at index 1, the third row at index 2. So if I want the first row, I can just say that at index 0, I want all. So if you want all, then you normally represent it in a full colon, all, okay? So if you run this one, then you're getting the first row here, the first row, okay? The first row. Then let's say you want the second column. So the second column, you're basically saying that in all these rows, please, I hope you can see this one. In all these rows, the first row, the second row, and the third row, I want the second column. So the second column is represented as 2, 5, and 8. So therefore, it is at index 1. This is the first column, index 0. The first column at index 0 is here. The second column at index 1 is here. So this is what we call now, for all the rows, I want the column at index 1. So it's the second column, which is here. So this will be very, very useful, especially when you want to extract information from data that we represent it in a table format. So I'm sure they're going to make sense later, as now we'll be doing data represented in a CSV file or a data represented in an Excel file. Okay, so this is actually how you can extract information from a 2-dimension array. So you have to specify the rows and the columns, okay? So any question up to there, I think I wish to share it on. You can try. So in case you have a question, feel free to ask. Feel free to ask. So that is now how to get information from a Numpy array. So now we go to objective number 4. So in our fourth objective, yes, I'm told to pardon on slicing a 2D array. Yes, let me go there again. So if you have a 2-dimension array, so we say that 2-dimension array is an array that is represented in rows. So I can just say 2D, it is an array that has been represented in rows and columns. That one. So the first value represents the rows. The next value represents the columns. Okay. I didn't share the one thing. Sorry. Yeah, sorry for that. So I was talking about so 2D array. So 2D array is an array that has been represented as rows and columns. So the first option you put here is for the rows. The second option you put here for the column. So for example, if you have this kind of an array, we have how many rows are here? This is the first row at index 0, second row at index 1, third row at index 2, okay? At index 2. So if you want the first row, then you have to say that at index 0, the first row, this is the first row, I want all the items. So this is actually how you represent all, okay? Or you can also say at index 0, I want items from index 0 to index 2. So you actually you'll only get 1 and 2. So in the first row, I want from index 0 up to index 2, but I think it should now be a bit confusing. You just say we want all for now. So at index 0, which is the first row, I want all the items. Now you're getting this one here. In the next phase, let's say you want to get the second column. So the second column, it is at all the records. For all the records, I want the second column, okay? I want the column 2 for record 1, column 5 for record 2, column 8 for record 3. So for all the columns, for all the rows, I want the second column. So I think this would actually make much more sense if you're actually working with a real data set. And you're going to see that one tomorrow as we'll be discussing about pandas. Okay. As we'll be discussing more about pandas. Okay. Now moving further, now we are talking about mathematical operations. Okay. Mathematical operations. I think these are actually straightforward. Mathematical operations. So that was our objective 4. So that now we're able to do data manipulation. So objective 4 was now doing mathematical and statistical operation. That was our 4th objective. So we're almost done. That was our 4th objective. And now you're seeing that if you have such kind of an array, so this one, you can be adding the scalars. So here, if I have this an array of items 1, 2, 3, 4, 5, no, 1, 2, 3, and 4. If I add 2 to each array, let me run this one. If I add 2 to each array, so 1 will be transformed to 3, 2 will be transformed to 4, 3 will be 5, and 4 will be 6. So you can actually add a scalar. So a scalar is an item, it's a value that will be added to each item in an array. Alternatively, you can multiply each item in an array by a certain scalar. Like I can say, I want to take each item in this array, I multiply them by 2. And then you're getting another output here. I think it's also self-explanatory, whereby you actually applying scalar operations to those items in a Numpy array. So proceeding with this one, we can also have two arrays, but they should be of the same. They should be of the same. They should be of the same. Space separator here. They want a new code cell. You can also have. So the first array we have 1, 2, 3. The second array we have 4, 5, 6. So if you run this one, we can actually add them up. 1 plus 4 is 5. 2 plus 5, we get 7. 3 plus 6, we get 9. So we have actually added the first array, the second array. So here is that the array should be of the same format. It should be of the same format here. Okay. So this is actually mathematical operation. Let's even try statistical operation. So for example, if you have such kind of an array, so the first operation was mathematical. So more of these ones, we're going to do them in real world data sets. So for here, we're just seeing how to work with them. So this is mathematical. This is mathematical operations. How about if you try B in a new code cell? Let me share this one. I hope I've shared it. I don't know. Let's share again. So this is mathematical operations. Mathematical operations. And now we are also trying statistical operations. So 2. And you're going to see that this will actually help us in data manipulation. So statistical. So for example, if I have this one, I should be having something like this one here. So just copy. Control copy. And I can paste it here. So if you have an array of numbers between 1, 2, 3, 4, and 5, So if you run this one, if you get the mean, you're being told the mean is 3, the median is also 3, the standard deviation is 1.4. We also have so many operations. For example, you can also say, can print, we have so many of them. NP dot, you can also get a variance of the array. So if you're doing statistical operation, you can also get the variance. So the variance is 2. The dispersion rate is 2. We can also have the NP dot, is it sum of the array? So you can also get the sum. The total sum is 15. So we have so many. I've just wanted to list all of them because we are going to apply them in our real world data set. So we also have NP dot minimum dot maximum. So the minimum value is 1. It should be 1. The maximum value should be 5. What else? The count, yes. Finally, you also have the count. So if you print NP, we can even sort them up, but they are already sorted. They are already sorted. Yeah, they're already sorted. But if you want to sort them in descending order, then you can say ascending. Is this one, or is it in pandas? I think this is in pandas, so you're going to do them in pandas. So we can sort them here, and also we can get the count. So you can also get the count. So print using Numpy. Let's get their difference. This not doesn't make sense here for now. I just wanted the count. Yes, print using Numpy. We want to get the count. I think this is actually on pandas. So I think those are the operations you can apply to a Numpy array. So you can actually get the mean, median, standard deviation. Should also have the mode. It also have the mode. The mode. Yes, you should also have the mode for the array. So here we are getting the mode, yes. And so many other, I think the mode is not here. I think we are going to take this one on our Panda series. So if you run this one, you're actually seeing that we can actually apply statistical operations to our Numpy array. So we're getting the mean, the median, the standard deviation, the variance, the sum, minimum, the maximum. We can sort them, and so on and so forth. So I'm sharing this one. And all this one, we can actually do them with the purpose of data manipulation. So finally, in Numpy, you're also able to do sort reshaping and transposing with the purpose of transforming this data set. So that was the 5th objective, the last one. So objective 5. Objective 5, we can also have the reshaping and transposing. That one. So that was the 5th objective in Numpy. So if you look at this one here, for example, we can start with reshaping. We can start with number 1, reshaping. When you want to do a rearrangement, you want to transform the rearrangement. So initially, this is actually So let me first print the array so that you can clearly see that one. And then I can put here a separator. Put here a separator, that one. So now you're seeing that initially this was a 3x2 matrix. So we had 3 rows and 3 columns. So it was a 3x3 matrix. So pandas will allow us to do a reshaping, whereby you can now rearrange the rows and columns in such a way that I can actually say that I want to reshape this matrix into a 3 rows and 2 column matrix. So now we are getting 3 rows, 1, 2, 3, and now 3 column matrix. So this is what we call reshaping. Very, very useful, especially when you want to transform your data set. So you want to transform your data set from a 3x3 to a 3x2 matrix. Then finally, we can also have transposing to, we can also have transposing, can actually have transposing, and it has actually been clearly shown here. So let me have this array to clearly show you that one. So this is my array. So if I print it here, the array, I hope you're seeing that this is how it looks like. It is actually a 3x3 matrix. So if I create a variable called transposed, and I take my array dot transpose, let me see what happens. So if I print transposed, I think I need a separator here so that now we can see the difference. So I can have separator here. So if you run this one, I hope you can see now the difference. If you transpose it, the rows will be the columns and the columns will be the rows. I hope it makes sense. So initially we had, these were the rows. I hope you can see, if you transpose a matrix, if these were the rows, the first row, the second row, now they become a column. This row is represented as a column. The next row is represented as a column. And now each column becomes the row. So that is actually how to actually transform your Numpy array. So reshaping is whereby we actually, first share these codes, then we can describe them. Share this code, that one. 55, reshaping and transposing matrix. That one here. That one. So reshaping is whereby we are actually rearranging the Numpy array. So let's say if it was from a 3x3 matrix to a 3x2 matrix, then transposing is whereby we are actually converting rows as columns and vice versa. So you've done like almost all the aspects in Numpy. So if you get your time, please go through all these operations. So now tomorrow we should be now ready to start on pandas. So let me just have a quick recap of what we've done. So today we had 5 major objectives. I hope at least you've understood at least 3. The first objective was now you've understood that what is a Numpy array and what are their properties. So a Numpy array is an array that can be represented in several dimensions. And the property it has is we have properties to do with shape, dimension, size, and data types. So those are the properties of a Numpy array. So we have the shape, we have the size, we have the number of dimension, and we have the data type. That was the first objective. The next objective is how do you create an array using built-in functions? So we saw that we can create an array either by using zeros and ones function. We can also use an array to create an identity matrix using the I. We can also create array using random arrays, and you can create array using some sequences. So in our third objective, we saw how do you get information from the array. So you can actually index items from an array, or you can also slice items from an array. And then now the fourth objective was how do you perform mathematical operations? So you can actually do some mathematical operation. You can also perform some statistical operation. And then finally, how do you reshape and transpose your matrix? You can actually reshape it by rearranging the Numpy array, or you can also transpose in such a way that you're converting rows as columns and columns as rows, which I'm calling vice versa. So basically, that marks the end of Numpy. And now tomorrow we'll be transitioning to pandas. And now we can combine these two now to use them in our data visualization classes. So any question from there? Any question up to there? Any question up to there? Any question up to there? So I wish to share this one with you. Anyone who wants to do some practices, I'll share that piece of Colab for you to try out. So any question up to there? Okay, so if there's no question, okay, thank you. I can see Sharon, you're saying you want to see where we can, we'll be applying them in so many applications. These are basically the foundations you need so that now you're actually very good in your data analysis or data science projects. And the first one that we normally do is Numpy. So if you're good in Numpy, tomorrow we start with pandas. We go to pandas, and then now we do matplotlib. Then we should be ready for our exploratory data analysis. So the key point is to understand the basics. We start with Numpy. Tomorrow we transition to pandas, and then we do matplotlib. So any other question or concern you have? Okay, so looks like we're good. So therefore, I wish to stop the class at this point.
Excuse me, sir.
Yes.
I've asked a question. What does the one in the under the 3D array in the number of dimensions? We have 1, 3, 2. What does the one represent?
Here is in this array.
In the 3D array, yes. When you are taking us through the properties under number of dimensions.
Here.
Yes.
Okay.
Like so, in that section, what does the first two represent?
Okay, yeah. So if you're actually doing something in a 3D, if you've done some, let me use something like a Cartesian plane or something like a cube. Let's talk about a cube. Let me draw a cube here. So let's have a cube. Cube right there. Just to demonstrate what I mean. Yes. So if you have something like this one, so this is what we view something in a 3D. So in a 3D, it means that this is the first dimension. This was the 2. Okay, this was the 2. So this 2 here has been represented by this length here. Then the other 2, this is the x-axis. Then this is the y-axis. This is the other 2. This is the other 2 here. And then finally, this is the z-axis. So it's actually a 3-dimension. It's a 3D. 1, 2, 2, and then 2. If you're doing something in a 2-dimension, so let me just say 2D, 2D. Then 2-dimension, we normally have only X and Y. I hope I should have had that. 2D, let me just say graph. 2D graph. But I think they'll make much more sense if we now be doing them in real world application. For example, this is the X dimension. This is the X dimension. This is the Y dimension. Oh, so this should be the X dimension. Then this should be the Y dimension. So if you are to view it in a 3D, then you could add a Z dimension here, Z. So that now you get a cuboid. But I think I'll be sharing a code tomorrow. I'll be sharing a code tomorrow so that now we can clearly differentiate between a 1-dimension, a 2-dimension, and a 3-dimension. Because a 1-dimension is basically a line. A single line is a 1-dimension. If you have this one line crossed with another line, this is a 2-dimension. This one line and another one is a 2D. Now, if you have one line, 2 line, and another line here, then that is a 3D dimension. It's a 3-dimension view that you're going to see later in our applications. I hope I've tried to clarify something.
Yes, thank you.
Okay. So because that one, I feel like it does not make much more sense. I will be sharing a code tomorrow. I will be before we start on Numpy, I will be demonstrating using shapes on how to view a 1-dimension, a 2-dimension, or a 3-dimension array. So that now, clearly, if you are now applying them in our data science or data analytics skills, they'll make much more sense. So any other question? So yes. So what does 1 in the 3-dimension array represent? So I think this is what what I'll do. I'll have to share the programs. I'll have to share the code tomorrow so that now we can clearly understand it. But to start us off, a 3-dimension is something like a cuboid. So if you have something like a cuboid, just say 3D graph. Then these are 3-dimension graph. I hope you can see we're actually getting a space. I hope you can see, like this one is clearly showing us a 3-dimension. So we have, I hope you can see we have X, we have X, we have Y, and we have Z. This is what we call a 3-dimension graph. X, Y, Z. So if you're actually doing data visualization for a 3-dimension graph, we'll be drawing graphs like this one here. This is actually a graph that has been represented in a 3-dimension because this is the first dimension, this is the next dimension, this is the third dimension. So we have the length, the width, the height, the first dimension, the second dimension, the third dimension. These are now what will be. These are the shapes that you can draw using 3-dimension arrays. First dimension, second dimension, third dimension. So if you say 1D, just to try and explain them. If you say 1D, then this is just a 1-dimension, just a line. Like this is just a 1-dimension, just a line. 1 dimension. Like this is a 1-dimension. 1 dimension. This is 1 dimension. But I think I'll be clarifying them more tomorrow. So any other question up to there? Any other question up to there? Okay, so if there's no more question, let me stop there for today. Please go through the recorded session. I know it's a very long session. It's gone through a lot. So now tomorrow we are ready to apply Numpy in our pandas classes. You're going to notice that pandas is built on top of Numpy. So for you to clearly understand pandas, then you need some knowledge to do with Numpy. So up to there, let me stop at that point. we have our pandas classes tomorrow. So have a nice day and see you tomorrow. Bye-bye.